Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
So some of you noticed the recording last Monday. It took a while to come up. They don't know what went wrong, but they managed to recover it. So when you go to Echo 360, there's something called recovered. That's the one you want to go to. If you go to the one that was actually Monday of last week, it doesn't work. So if you go to the one called recovered, it is working in there. So today we talk about the Greek letters, which is essentially a way of managing the risk of your options. Okay, so that's what we're going to talk about today. Just as an update, remember you have a quiz next week, your fourth quiz, and then the week after that you have your fifth and final quiz. Okay, so we took a vote, and the vote was to make it the best 4 of 5 rather than 5 of 6 quizzes. Okay, so I will put up a practice quiz for what would have been this week in the next couple of days. So we're going to go through the Greek letters, and then we're going to go through a couple of past exam questions. One exam question on the Greek letters, which is fairly straightforward, and another one which is a type of extension question, okay, where you've got all the skills, trust me, to answer the question, but it's how you interpret it and put different concepts in the course together to actually be able to come up with the solution itself. So, is that mic actually working? I just want to make sure it's being recorded. Okay, that sounds better. Okay, so the Greek letters. So there are 5 of them that we talk about, but 4 of them we only talk very briefly about. Okay, so you've kind of got to know the definitions for them, but the main one we focus on is something called delta. Okay, and it's called delta hedging. Okay, so delta hedging is all about what we call maintaining a delta neutral portfolio. Okay, and so to maintain a delta neutral portfolio, you've constantly got to balance your position in the underlying asset to keep your portfolio what we call delta neutral. Okay, so let's talk about the 5 Greek letters, and it's all about essentially how the option price can change when certain variables change. So delta, which is the main one we focus on, that's all about the sensitivity of the option price to changes in the underlying asset price. So what we mean by that is, if you've got an option on gold and the price of gold changes by a certain amount, what happens to the price of the option? Okay, does it increase, does it decrease, and by how much? Okay, and that's the main one we focus on in this week's lecture. We also have gamma, which is a measure of delta's sensitivity to changes in the underlying asset price. So how does delta change as the underlying asset price changes? And you'll see as we go through the lecture that delta is not a straight line, okay? It's increases at an increasing rate, okay? So there's a curve. We draw a tangent to the curve to find what delta is at a particular point in time. And then vega, theta, and rho, they're easy to remember. V for volatility, T for time, and R for risk-free rate. So that's all about the sensitivity of the option price to changes with vega to volatility. So as volatility changes, how does the option price change? By how much? Theta, as we change the time horizon, how does the option price change? And rho, as we change the risk-free rate of interest, how does the option price change? Okay, so you'll see it's all about what happens to the price of the option. Okay, so why do we care about it? Why do we care about the price of an option? So an easy way to, well, a possible easy way to explain that is that this gentleman down here, right, he has a portfolio. In his portfolio, he might have cash, he might have shares, he might have property, and he also has written some options. Okay, so he's the writer of options. So we know that at the very beginning, he received a whole lot of money to be the writer of the options. Okay, let's imagine he received $100 million to be the writer of these options. So he faces a risk. What's the risk that he faces? That what will happen to option prices if he's the writer? What's the risk he faces? Option prices can go one of two ways. What's the way that will affect him? If they get exercised, yes, but more than that, what has to happen to the option prices to make him worried? They increase, right? They increase. Why is that a concern? Simply, you can think about it. If they increase, that means they're more likely to be exercised, right? Option prices go up, right, when the payoff in the future is higher probability of getting that option payoff. Okay, so that leads back to his statement about them possibly being exercised. But more than that, he's got this portfolio of 100 million options. How does he get rid of those options? Just imagine he no longer wants to be the writer of the options. Right? This gentleman over here is now going to be the writer of the options. What does he have to do to make him the writer of the options? He doesn't just give them to him. What else has to happen? He has to pay him the premium. So he has to pay him $100 million. Now, if he received $100 million at the beginning for those options, cancels out, that's fine. But let's imagine the price of these options goes up to $110 million. Okay, so initially he received $100 million to be the writer. He no longer wants to be the writer. He wants to liquidate his portfolio. He has to pay this gentleman over here $110 million. Okay, so ignoring the time value of money, essentially he's $10 million worse off. Okay, so that's what we're trying to do today. We're trying to hedge the value of his options. Okay, and mainly we think about this from the writer's point of view. Okay, we can also think about it from the holder's point of view, but it's mainly the writers who want to hedge the value of their options. Okay, so by hedging we simply mean we want to make sure that the value of the options doesn't change. Okay, or a portfolio that includes the options doesn't change in price. Okay, and that's what delta hedging is all about. Okay, so really important. What is delta hedging? Okay, so delta hedging is maintaining a delta neutral portfolio. Delta changes through time, so every day, every week you have to rebalance your portfolio to make sure you have a delta neutral portfolio, which means you're going to have to be doing some buying and selling of certain assets. And that is expensive. Okay, so that's an expensive path to possibly go down, and we'll show some examples of that later. Okay, so that's the basic premise behind what we're trying to do here. Okay, so delta, how does my option price change as the price of the underlying changes? Right, so the sensitivity. And so let's imagine that we have a delta here of 0.5. So all that means is if the price of the underlying asset changes by a small amount, the price of the option will change by half the amount. Okay, so if the underlying asset goes up by 5 cents, we'd imagine the option price to change by 2.5 cents. Okay, 50% of the amount. Okay, so it's just a measurement of how the option price changes when the underlying asset price changes. And we look at delta in terms of a curve. Okay, so this is the relationship. Sorry, over there. This is the relationship between, on the bottom, what happens to my stock price and what happens to the option price. Now this is for a call option. Okay, because as the stock price goes up, with a call option, your payoff is ST minus X, your payoff is going to be higher. Therefore, the option price will go up. But notice how this curve here is not a straight line. Right, obviously out here you're really in the money. Okay, you're really in the money, the option's certain to be exercised, ST minus X is a huge amount. Okay, so you get a huge payoff, right, so the option's going to be more expensive. So what that straight line is, that's just taking a tangent. That's just measuring what is the slope of the curve. Okay, what's the gradient of the curve? So in this example before, that's 0.5. Okay, but down here, it could be 0.2, and up here it could be 0.8. Okay, because it's a steeper curve. So as prices change, and this is one of the concerns with delta hedging, as prices change, down here delta's quite low, up here delta's quite high, you've got to do more things to maintain your delta neutral portfolio. So what is a delta neutral portfolio? It means you want to have a delta of 0 on your portfolio. So if one option has a delta of 0.5, then to make it delta neutral, you need to find something with a delta of negative 0.5, so that the 0.5 and the negative 0.5 cancel out. Okay, so how do we measure it? We'll do the kind of the intuition side about it, and then we'll talk about, it's really easy, you just essentially use ND1. Okay, so ND1 from our Black-Scholes gives you the value of delta for a call option. Okay, but the other way you could do it is you could look at physical data out there. So you could have a look at some call options and whatever the underlying asset is. And you have a look. So today, the asset price changed by whatever, 5 cents, and the option price changed by 2 cents. So it's just going to be 0.02 divided by 0.05 will give me my value of delta. Okay, but delta only works for small changes, obviously. If we go back to this plot here, if there's a small change, then you're at about the same delta. But let's imagine there's a huge change. The stock price goes up here. Delta's got to increase by a lot. So whatever strategy you've put in place, which we'll talk about in a minute, won't actually work. So that's another problem. Delta hedging only works for small changes in the underlying asset price. Okay, not for big changes. By the way, your quiz next week is a theory question. Okay, so it's a theory question on delta hedging. Okay, so delta hedging only works for small changes in the stock price. Okay, so here we have an example. On one day, the stock price increases by 2 cents and the option price increases by 0.8 of a cent. Okay, so these are very small changes in the underlying asset price. My 0.08 divided by my 0.2 gives me 40%. Okay, so when the stock price changes by a small amount, I expect the option price to change by 40% of that particular amount. So we've spoken about that. Okay, so let's have a look at an example about how we'd make a delta neutral portfolio. So let's imagine we have 2,000 call options. And we have a delta for those call options of 0.6. So that means when the price of the of the underlying asset changes by a small amount, the price of the call option will change by 60% of that amount. Okay, and we are the writer of this particular call option. Okay, so what is my current total delta? If an option has a delta of 0.6, what's my total delta? Not a trick. One option has a delta of 0.6, so 2,000 options will have a delta of, sorry, times 2,000, right? So we've got 2,000 call options. So I'm wanting to calculate my total delta. The delta of one call option is 0.6. So the total delta is going to be 2,000 times 0.6. Okay, but as the asset price increases, am I worse off or better off as the writer of a call option? I'm worse off, right? Because I've got to pay someone more money. So really I've got a negative delta. I'm negatively impacted if the price of the call options goes up. So I've got a total delta of negative 1,200. What is delta hedging? Who can remember? Important for your quiz next week. What is delta hedging? Maintaining A delta neutral position. So what do I need to find? Something with a delta of? Okay, so I need to find a delta equal to positive 1,200 to cancel out. So what do you think has a delta of positive 1 always in regards to this particular option? What will always have a delta of positive 1? The underlying asset, right? So if the underlying asset price goes up by $1, it goes up by $1, right? So it's perfectly positively 1, the underlying asset. So to make it delta neutral, you need to buy, right? Buy the underlying asset. Why buy the underlying asset? Because the underlying asset has a delta equal to positive 1. If the price goes up by $1, it goes up by $1. So if this is 2,000 call options on shares, how many shares do I need to purchase? Not a trick again. I need to have a delta of 1,200, and one share has a delta of 1, so I need to buy 1,200 shares. Right, so now my delta with my options is negative 1,200, and my delta with my shares is positive 1,200. So I am delta neutral. Okay, so now no matter what happens, my total portfolio shouldn't be impacted. Okay, so now my portfolio is not equal to 2,000 options. It's equal to 2,000 call options and buying 1,200 shares. That's my portfolio. Okay, so let's have a look at this works. Okay, so let's imagine that the current share price, okay, so the current share price is equal to $100. And let's first of all imagine that the share price goes up by $1 to $101. Okay, so let's first of all look at my options. Now my options were worth $10 each. So if the share price goes up by $1, what will each option now be worth? Remember, delta is equal to 0.6. What will each option now be? They'll go up to a price of $10.60. Fantastic. Okay, just price goes up by $1, delta is 0.6, so it must go up by 0.6 of a dollar. So it goes up by 60 cents. Okay, so what is my loss on my options? Remember, you're the writer. Well, you've lost 60 cents per option because you'd have to pay someone 60 cents more now to be the writer. You own 2,000 of these options, so you are $1,200 worse off. But your shares, well, you've bought them, they've gone up $1 each, and you own 1,200 of them, so you make a profit of 1,200. So net, the whole portfolio's value has not changed. Net, zero change. So this is delta hedging. It doesn't matter that the price of the option's gone up. Because you own the shares, you're no worse off and you're no better off. Right? That's what hedging's all about. Right? Locking in the value. Now let's imagine that the share price falls. Okay, so the share price falls to $99. Okay, I can be no worse off, I can also be no better off. Okay, so my options, what are they now going to be worth? Okay, so let's imagine I've gone from $100 to $99. Your options will have fallen by how much? 60 cents. So they'll be worth $9.40. Okay, you've gone from $100 to $99. They've fallen $1, so the option price has fallen by 0.6 of that amount. They've dropped by 60 cents. So now on my options, well, I've actually made a gain, right? I received $10 at the beginning per option. To get rid of it, I'd have to pay someone $9.40. So I've made a gain of 60 cents per option. I own 2,000 of them, so I'm $1,200 better off. But my shares, well, I've lost $1 per share. I owned 1,200 of them, so I lose 1,200. Net change of 0. Okay, so delta hedging is about creating a portfolio, and no matter what happens, the value of the portfolio doesn't change if there's small changes in the stock price. If the stock price had gone up by $50 in one day, this would not have worked. Okay, delta would have been something like 0.9. Okay, and it would not have worked. So it only works for small changes in the stock price. Are there any questions on that example? Okay, so that's just trying to show you the idea behind it. We'll do some more examples and calculations as we go along. Okay, so that's just from this example here. Okay, we're never going to, well, very unlikely I'd give you changes in stock price, changes in the price of the option. I'm going to ask you to calculate delta. Okay, and I'll ask you to calculate delta using essentially the Black-Scholes option pricing model. So the great thing about the Black-Scholes option pricing model is that ND1 gives you delta. Okay, it gives you the sensitivity, so I should say that, it gives you delta for a call option, ND1. So ND1 gives you the sensitivity of a call option price to changes in the value of the underlying asset. ND1 minus 1 gives you the delta for a put option. Okay, so ND1 is the delta of a call option, ND1 minus 1 is the delta of a put option. So no new formulas to learn. Everything you've done the last few weeks, whether I ask you to calculate delta on a non-dividend paying share, delta on a currency, delta on a futures, delta on an index, you've done all those formulas before. Okay, so no new formula to learn. Okay, but you need to know that you have to calculate ND1. And then you need to know the position you take in the underlying asset. So with a call option, you take the opposite position. So if you're long in a call option, then to make it delta neutral, you'd take a short position in the underlying asset. Okay, so short sell the underlying asset. If you're short in a call option, you take a long position in the underlying asset, a bit like in the example we just did. And the position you take is ND1. So if you calculate ND1 to be 0.6456, then you're going to multiply 0.6456 times the number of options you have to work out your position in the underlying asset. Okay, is everyone okay with that? So with call options, you take the opposite position. Long in a call, short in the underlying. Short in a call, long in the underlying, to a value of ND1. With a put option, as I said, it's ND1 minus 1. And with a put option, you take the same position. Okay, so if you're long in a put, to make it delta neutral, you'll be long in the underlying. If you're short in a put, you'll be short in the underlying. And that makes sense because you're looking at the other side of it. Okay, you're kind of looking at the opposite side. Okay, if stock prices go up, right, that's bad now for a put option payoff. Okay, so you're thinking about the other side of it, which is why you take the same position rather than the opposite position. With a call, prices go up, that's good for option prices. Puts, prices go up, that's bad for put option payoffs. So if you're the writer, you want prices to go up. Right? Whereas with a call option, if you're the writer, you want prices to go down. And the position you take is you calculate ND1 and you subtract 1. Or whichever way around you do it, I don't care. 1 minus ND1, ND1 minus 1 gives you the same number. What students always have trouble with is they do this and they get negative or they get positive numbers and they worry. Don't worry. Just remember the rule. People think, oh, it's negative. Does that mean I take the opposite of what I meant to do? No, it doesn't. It's always the same rule. If you're long in a call, you're going to be short in the underlying. If you're short in a call, you're going to be long in the underlying. Fantastic. A put. If you're long in a put, you're going to be long in the underlying. So don't worry if you've got a negative or positive sign. Ignore it. Think of it almost like an absolute value, okay, when you do ND1 minus 1. Okay, or 1 minus ND1, you'll end up with a positive number. Just think of it like an absolute value, but you take the same position with a put. Okay, you take the opposite position with a call option. Okay, are there any questions? Yeah, so we're going to do some examples. So imagine you had 2,000 options, right, and each option was over 1 share. Then you'd say 2,000 times the delta you've calculated. But imagine you had 2,000 options and each option was on 100 shares. You'd have to say 2,000 times 100, right, times the delta. So you need to look at the total position of your underlying assets. So how many shares have you got options over? So if each option's over 1 share, that's easy. But if each option's over 1,000 shares, you need to work out the total underlying position. Okay, and multiply your ND1 by the total underlying position. Okay, or your ND1 minus 1 by the total underlying position. And then obviously, when you start looking at indices, currencies, and futures options, then the ND1 you're going to use is going to be the ND1 for currencies, for indices, okay, and for futures options. But there's an extra step you need to make with those ones. Okay, you're going to calculate ND1, and then you have to multiply it by e to the negative QT. Right, so again, you need to go ahead and remove the dividend yield, remove the foreign risk-free interest rate once you've calculated ND1. We'll show that in a few minutes as well. Okay, but nothing new in terms of what you're doing here, right? Nothing new in terms of what you're doing. Okay, it's just the way to think about it. Okay, so obviously that's RD1. So let's have a look at an example. So you've sold call options, which means you're the writer. Immediately tell me, what position will you take in shares? Long, wrong. That's right, long. You've sold the call, you're the writer, opposite position. That means you take a long position. You're going to buy shares to make this delta neutral. Okay, so there are over 50,000 shares. Immediately in your head you think that means once I calculate delta, I'm going to multiply it by 50,000. And that's how many shares I'm going to have to buy. Because your total exposure is 50,000 shares. Strike price of 30, T is a half, S0 is 29, risk-free is 5%, volatility 25%. Okay, so we plug it into Black-Scholes, calculate my ND1, natural log of a spot price of 29 divided by the exercise price of 30, plus my risk-free of 5% plus volatility of 25% squared on 2 times half a year, divided by volatility of 25% times the square root of half a year, to give me 0.038. Now you would just look up 0.04 in your probability distribution tables. Remember, just round to 2 decimal points. So remember, P you round to 4 decimal points for binomial. ND1, ND2, you round to 2 decimal points when looking them up in the tables. Don't interpolate in the exam, right? You'll make a mistake, maybe, and I haven't asked you to. So just round to 2 decimal points. So you end up with a delta of 0.5160. So simply you take that 0.5160, you multiply it by 50,000 shares, and that's the number of shares you need to buy to make it delta neutral. So I buy 25,800 shares. Now, if the stock price goes up or down by a little bit, my total portfolio, which is the shares and the options, will not change. They'll have a value, excuse me, they'll have a value of 0, delta of 0. You won't make any losses, you won't make any gains. Remember, this is about hedging, okay, hedging the value of your options. So this is kind of just spelling out what I've said 3 or 4 times. Okay, so if I look at my call options, if I look at being long in a call option, well, ND1 is the delta of being long in a call option. When you look up any number for ND1 in the back of your textbook, it always gives you a positive number. which means the delta of a call option is always positive. To make it delta neutral, you need something with a negative delta. That's why you're short, or short sell the underlying asset. If the price goes up, you lose money, in other words, by shorting the underlying asset. If you're short in a call option, well, we know ND1 is the delta of being long in a call option. So if you're short in a call option, your delta is going to be negative ND1. So you're going to have a negative delta. To make it delta neutral, you need a positive delta, which means why when you're short in a call option, you have to buy the underlying asset, right? Taking the opposite position. What's the delta of the underlying asset? Positive 1, right? Positive 1. Put options. So the delta of a long put option is ND1 minus 1, which will always give you a negative number. So the delta of being long in a put is negative. To make it delta neutral, you have to have something that's positive. That's why you buy the underlying asset. Long in a put, long in the underlying asset. For a put option, if you are short in the put option, okay, you've written it, then your delta is negative of ND1 minus 1. So negative and negative is going to give you a positive delta. Okay, so by being short in a put, we end up with a positive delta. To make it negative, you need to make it neutral, you need a negative delta. That's why you short sell the underlying asset. Okay, but that's just a theory behind it, right, in terms of how we set up these portfolios. So when we start looking at currencies and when we start looking at dividend yields, then it's the same formula we used a couple of lectures ago. We now just say R minus Q, so we subtract the dividend yield, or we subtract RF, the foreign risk-free rate. We calculate D1, but then we also, you don't stop there, you also have to remove the dividend yield, or the foreign currency, once you've calculated ND1. Okay, you have to remove it. The reason being that we know that underlying asset, right, has a return, which is the dividend yield, or has a return, which is the foreign risk-free rate, so the price won't go up by as much. So you need to remove that amount to take into account the risk-free and the foreign risk-free and the dividend yield. So obviously, short in a call, you're going to be long in the underlying by e to the negative QT times ND1. And if you're long in a call, you'll be short in the underlying. E to the negative QT times your calculated ND1. And then if it's a put option, again, same as before, it's going to be ND1 minus 1, where you calculate ND1 using your R minus Q or R minus RF in the Black-Scholes formula. And then you multiply it by e to the power of negative QT as well, or e to the power of negative RF, remove the foreign risk-free rate. Long in a put, long in the underlying, short in a put, short in the underlying, okay, to make it delta neutral. It's dividend, it's Q, risk for currency, it is RF. And if it's a futures contract, okay, then you have Q equal to the domestic risk-free. Okay, so you have R, e to the power of negative R times T. So let's have a look at an example. How would you implement a delta hedge with the following information? An Australian bank has sold 6-month put options, so what position will we take in the underlying asset? You've sold put options, so you're going to take a short, same position. Remember the put, it's the same position. You're short in the put option, so you're going to be short in the underlying asset. So an Australian bank has sold 6-month put options on $1 million US with a strike price of $1.25. $1 equals $1.25 Aussie. The current exchange rate is 1.27. Risk-free in Australia is 5%. Risk-free in the US is 2%. Volatility of the US dollar is 20%. So we know we're going to need to be short in US dollars to make this delta neutral. We calculate ND1 and then we remove the US risk-free rate from it. So my natural log of the current spot price is $1.27. My exercise price is $1.25. Australian risk-free is 5%. US is 2%. So that's my foreign rate. How do you know in the question which one's foreign, which one's domestic? You're told it's Australian bank, right? It's an Australian bank dealing in US dollars. Okay, so the domestic risk-free is Australia, the foreign risk-free is the US. We have a volatility of 20% squared on 2 times 6.5, half a year, and volatility of 0.2 times square root of 6.5. So that gives me 0.6141 for my ND1. Because it's a put, I subtract 1 from it, and then I remove the US risk-free rate. So e to the power of negative the 2% US risk-free rate times half a year to give me negative 0.382. Ignore the negative 0.382. Ignore the negative sign. Don't ignore the 0.382. Take the 0.382 and then you multiply it by your total currency exposure. And we know you need to take a short position because you're short in the put. So 0.382 times my 1 million US dollar means I need to go short 382,000 US dollars. Okay, to make this portfolio delta neutral. Any questions? So in a way, this is actually simpler than doing a Black-Scholes problem, right? All you have to solve for is ND1. You don't have to solve for ND2. You don't have to plug it back into a formula. You're really just doing one step and then multiplying it by the underlying exposure. Okay, so can we apply... actually, before we do that, we're going to go down to here, the problems with delta hedging. Okay, so delta hedging is about... What is delta hedging? Delta hedging is maintaining a delta neutral portfolio, right? So you don't lose money on the value of your portfolio, which includes your options. Okay, so we're not losing money, we're hedging the value of our options. The problem is, delta's not constant, right? If we go back to that plot at the beginning of the lecture, right, down here with the call option, delta's very low. Up here, delta's very high. Okay, delta's very high. So, in maintaining my delta neutral, or to be delta hedging, I've always got to have total delta equal to 0, right? So let's imagine you've got a call option, and you've written a call option. What position do you take in the underlying asset? Long. Okay, so let's imagine what happens when prices go up, when share prices go up. What happens to delta with a call option? It increases. Delta goes up. So what does that mean you need to do as the writer of these call options? As delta increases, to maintain a delta neutral portfolio, you have to do what? Buy more shares, right? So as delta goes up, it goes from 0.5 to 0.6. Rather than saying 0.5 times the underlying asset, that's the number you have to buy, it's 0.6 times the underlying asset. So as prices go up, you have to buy more shares. What happens when prices fall to maintain a delta neutral portfolio? You'll have to sell shares, right, because delta will fall. So the strategy here is to buy as prices go up and sell as they go down. So buy high, sell low. That's crazy, right? That's the reverse of what we tell you. Right? So you're going to buy as things become more expensive. So you're going to buy at the high point and then sell at the low point. Right? So if you're long in a call option, this is a very expensive strategy. Because you've got to buy expensive shares and then sell cheap ones. Right? That's the strategy. And it's constant rebalancing. Okay, nowadays you can get computers to do it, so it's maybe not that labor intensive. But imagine if it's you by yourself. Every day you have to go and have a look, calculate the delta, rebalance it, so it takes resources. Okay, so it's not an easy process, it's time consuming. And you've got to constantly rebalance it to make sure your total delta is equal to 0. Because if you've got a positive or negative delta in there, you haven't hedged properly. What's the other main problem with delta hedging? Probably the most important one. It only works for small changes, right? Only works for small changes. What do I mean by a small change? I mean if the stock price changes by less than 1%, right, then you're probably okay. If the stock price changes by 2, 3, 4%, which can happen, right, regularly, then your strategy hasn't worked. So you've got this very expensive strategy. It takes a lot of time and it doesn't actually work most of the time. Okay, that's not a good story to sell, right? That's why you might have a look at things like gamma, right, which look at the sensitivity of changes in delta, okay, beyond the scope of this course, right? But that's where you'd start looking at doing things like that. And then if you looked at volatility, time, risk-free rates, then maybe you can get a really nice hedge portfolio. But now you've got to be hedging based on 5 things rather than 1 thing. Okay, so it's also very time-consuming. Okay, so we can hedge options, but maybe we also want to hedge other contracts out there. Okay, and the other sort of contracts we can hedge out there are forward contracts. Okay, so now I have to think about what's the delta of a forward contract. Well, my payoff, if you like, at the end is, depending on which way, it's either the futures price minus the spot price or the spot price minus the futures price. Okay, so we think about it kind of at expiry. As the asset price changes by $1, what happens to the payoff from your contract? Or what happens to the forward price? Well, basically it changes by the same amount, right, as you get closer to expiry. So if you like, we assume that the delta of a forward contract is essentially equal to 1, which makes it very simple. Okay, if you're short 10 forward contracts, to make it delta neutral, you'd be long 10 units of the underlying asset. Okay, 10 shares. Okay, so the delta of a long forward contract is 1. The delta of a short forward contract is -1. So if you're long in a forward, you'll have to be short in the underlying. If you're short in a forward, you'll have to be long in the underlying. They completely cancel each other out. What if it pays a dividend yield? Well, then you just remove the dividend yield. E to the power of negative QT times 1, because that's its delta. So it just becomes e to the power of negative QT. If it's a foreign risk-free, sorry, if it's a currency, then it'd be e to the power of negative the foreign risk-free rate. Okay, times t. Okay, so we just remove that from the dividend yield. Sorry, from the delta. What about futures contracts? It's not examinable, but it's interesting to talk about. What do you think we do with a futures contract? What do you think the delta of a futures contract is? How are futures contracts different to forward contracts? Forward contracts, basically you wait till expiry. You get your gain, that's why the delta is only 1, right? Because it all happens at expiry. With futures contracts, you have marking to market. Right, so you might remember this from earlier on in the course. As prices go up, if you're long in a futures contract, you get more money put in your margin account. And your margin account usually earns the risk-free rate of interest plus a certain amount. Normally, say, 50 basis points, 0.5%. So what do you think would be the delta of a futures contract, given that? It's not equal to 1. Essentially, you're going to have to put in the risk-free rate of interest as well. Okay, because you earn the risk-free rate of interest on the amount that's in your margin account. Okay, but that's an approximation, right? Because if prices don't move, well, then you don't really earn anything. Okay, so it's an approximation of what you would do in that particular situation. Okay, are there any questions on delta hedging? Okay, so I want to go through a couple of examples. Up to you, we can either have a break and then do the examples, or we can keep going and do the examples and finish early. What would you prefer? Would you like to get up? A break? Okay, so if you want to have a break for until a couple of minutes before 10, and then we'll do these examples. Okay, so one of them is a one that you may not have seen before, but I'll walk you through it. If any questions, please come up and see me. Yes.
Because it's going to grow by that amount less than we have, right? So it's not going to be like 0.9, whatever the risk is. Let's say the risk front risk is 2%, so it's 0.9, right? Because it's not going to grow by that amount unless you get that return. Because the FOMC are minus R. Yeah, no, we just simply remove the foreign risk free rate. Because when you buy US dollars, you're not getting domestic risk free, you're only getting foreign risk free. Okay? So essentially, you're not getting domestic, so that's why it's just that. Is that right? Yeah, you're getting. Okay. All right, thanks. That's right.
Okay, so let's have a look at a couple of questions. One is just a delta hedging question. So question 4A. An Australian bank has sold 13-month European put options on 100 million euros with a strike price of 1.43. 1 euro equals 1.43 Aussie dollars. The current exchange rate is 1.51. Risk-free in Australia is 4.5%. Risk-free in the Eurozone is 1.5%. Volatility of the euro is 15%. How would this bank implement a delta hedging strategy? You can assume Australia is the home currency and the Eurozone is the foreign currency. Okay, so my D1 in this case is going to be equal to the natural log of the spot price divided by the exercise price plus the domestic risk-free minus the foreign risk-free plus volatility squared on 2 times T divided by volatility times the square root of T. So in this case, D1 is equal to the natural log of 1.51 divided by 1.43 plus domestic risk-free of 4.5% minus Eurozone risk-free of 1.5% plus volatility of 15% squared on 2, and the life of the option was 13 months. And if I round to 2 decimal points, that gives me 0.63. So N of D1 is equal to 0.7357. So my delta is going to be equal to that minus 1, because it's a put option. And then I have to remove the Eurozone risk-free interest rate as well. And that gives me 0.2600398832. Okay, ignore negative, positive signs. Because I'm short in this put option, I know I need to be short in the underlying asset. So I'm going to have to go short 0.2600398832 times 100 million euros. So I go short 26,003,984 euros. But you're not done, right? Because you need to say, and I need to maintain a delta neutral portfolio through time. Okay, so this makes it delta neutral at one particular point in time. You have to constantly rebalance, okay, to make it delta neutral always. So let's have a look at a question that you may not have seen before. And this comes from the 2009 exam. Okay, so let's make it a little bigger. Okay, now that you've completed Foundations of Finance and Derivatives, you've decided to put your knowledge of options into practice. You've decided to create your very own over-the-counter option called the Canberra option. This is an option over the All Ordinaries Index in Australia. It has a life of 6 months and can only be exercised at maturity. In terms of the payoff from this option, if the value of the All Ordinaries Index falls between now and maturity, the payoff is 0. But if it rises between now and maturity, the payoff is a fixed percentage of the rise in the value of the All Ordinaries Index. Use this information to answer the following questions. Okay, so is the option described above a call or a put option? Straightforward, it's a call option, right? If prices go up, you get a payoff. If prices go down, you don't. Okay, so that's straightforward. Question B. If V is the current level of the Ordinaries Index, ST is the value of the Ordinaries Index in 6 months' time, and P is the fixed percentage that the purchaser of the option will receive if the All Ordinaries Index rises between now and maturity, what is the profit to the writer of the option if it is exercised? Any ideas where you'd start with this? Okay, so V equals the current level of the All Ordinaries Index. ST, yep. ST is the value in 6 months' time. So I just got that. P is my fixed percentage. Any ideas? What you would do? Okay, so remember you've been asked to write about this from the perspective of the writer of the option. Can't calculate ND1 with this question. Not even given enough information, unfortunately. Okay, so remember, the value of any financial asset is the present value of the payoff, take into account the probability of getting that payoff. Okay, so it's kind of like the starting point. Now this question's a little bit different though, right? Because it's not asking you for the value today, right? It's asking you for what's going to happen to the writer if this thing is exercised. Right, so how do I work out, so what are you told in the question, right? Let's go back to the, you're told with this Canberra option that in terms of the payoff, if it falls, the payoff is 0. But if it rises, the payoff is a fixed percentage of the rise in the value of the All Ordinaries Index. So how would you work out how much it's risen by, given the information you've got in the question? If they were numbers, you'd know straight away. Don't let the letters confuse you. How do you work out the return? ST is the final price, V is the current price. What is the increase? ST minus V. Okay, so ST, I'll put this up later. So ST minus V is going to be the rise in the index. Everyone happy with that? ST is the final price, V is the beginning price, right? The current level of the Ordinaries Index. And we're told that in the question here that it has risen. Okay, the index has risen between now and maturity. Okay, so ST minus V is the amount that it's written. What's the payoff? How much money do you get? Yep, ST minus V times P. Right? ST minus V times P, because P is the fixed percentage that you get if it rises. Are you done? You're the writer, so what is your payoff? If you're the writer, it's going to be negative. But you're told, asking the question, what is the profit to the writer? Right, so essentially it's going to be, this is a call option, it's going to be C, and I shouldn't have used P because that kind of makes it confusing. But it's going to be the call option premium minus the percentage increase multiplied by ST minus V. Okay, for this Canberra option. Let's have a look at a similar one. Again, these are all past exams that you've got up on Wattle. Okay, I'm not hiding anything here, so I just have to go to the website. So you can see in terms of thinking, it's not something that you wouldn't have learnt in the course, right, necessarily. Okay, it's not something you wouldn't have learnt. But you have to put some concepts together. And in fairness, next week we kind of look at exotic derivatives where we kind of build into this sort of stuff. So maybe I'm doing this a week too early, but it's never too early. So. In fact, actually, maybe I have it here. Maybe it's this one. Here we go. Okay. It's time to use the knowledge you have gained from derivatives to make some money. You've decided to start trading in derivative contracts. Don't do that, right? Please don't do that. As a result, you've created your own derivative contract. This contract will provide a payoff of a fixed $100, for every 1% that the All Ordinaries Index rises between now and December 30. If the index falls, the contract will provide a payoff of 0. Assume that L is the value of the index today, J is the value of the index on December 30, and S is the cost of derivative today. If you are the seller of this derivative contract, what is your profit from the derivative if the index goes up, and B, if the index goes down? So what is your profit if the index goes down? Sorry? What was the answer? So let's do part 2 first, because that's the easy one. What if the index goes down? What's your profit as the writer? Just S. Just S. Okay, the amount you've received. S is the amount that you've received. Okay, so let's do the harder part. First of all, if we build on from what we did before, what have we got here? J is the final price, L is the beginning price. How do I work out my percentage return? Okay, this is a percentage return. This one up here, remember, was a dollar return. So if J is the final price, L is the beginning price, how do I work out my percentage return? Yeah, that's right. What is it? Yeah, you can do it a couple of ways if you want. You can say J on L minus 1, or you could say J minus L divided by L. Same thing, right? Let's use the top one here. Okay, that gives me a percentage return. Right, so let's imagine that was 2%. How much do you get per percent return in the question? $100. So what would you want to do with this? Multiply it by $100. Then you do a sanity check. If this is 2%, 2% times $100 would give you what? $2. So what do you need to do? You don't get $2, you get how much? You get $200, right? So you need to multiply it by 100, right? So to get that 2% into a whole number, you'd have to say 2% times 100 to give you a whole number of 2, then times it by $100. Okay, remember this is, we're working out the profit. So now, what is this? Essentially here is what word do I use to describe this? This is the payoff. This is the payoff, right? So my profit, S minus that junk over there. And then if I was to be really, but that would have got you full marks. But if I was to be really picky, I would say, well, you're told that you get $100 per percent. So if this was 2.4, you're not going to get 2.4%, right? 2.4 times, you're going to get 2%. So you'd have to say rounded down to nearest whole number. Because you're told you get $100 per percent, it goes up. If it goes up 2.5%, it's only gone up 2%, so you only get $200. It's gone up 2.99, too bad. You only get $200. Right, so that is, and I could be really even pickier, right? I could take into account the time value of money, right? But I've told you with options we don't really, so I could say S multiplied by E to the power of R times T, right? Because you could have invested that money you got at the beginning, right, if I really wanted to, but I didn't. You'll see in the exam solution, right? Okay, but if I did say take into account the time value of money, you'd have to do that, right, if you got that in your question. Right, so you'll see next week, and we kind of do this next week, we talk about different times of derivatives, right? So far you know American and European, right? That's basically it. Right, so next week we talk about Bermudan options, right? We talk about shout options, look back options, right? Essentially you can create whatever you wanted, right? Some of them are useful, some of them are just to make money for people who write them. They have no purpose whatsoever, right? And we'll talk about those ones in next week's lecture. But as we go through next week's lecture, we'll talk about how would you actually value this option. All right, so let's give an example, right? And this could have been in your final exam, right, if we hadn't studied Bermudan options. But essentially with a Bermudan option, it's kind of a mixture between a European and an American option, right? European you can only exercise at the end, American you can exercise any day. A Bermudan you can exercise early for a specific time period or at the end. So imagine it's a 5-year option. You might be able to exercise it early between years 1 and 3, but you can't exercise it between years 0 and 1 or years 3 and 5, only at the end if you don't exercise it. So how do you think you'd value that option, knowing what you've done in the course? You've got enough to value it. How would you value that option? Would you use Black-Scholes or would you use binomial? Can't use both. You've got to pick one. Which would make the most sense? Binomial. You'd do binomial. You'd find the payoff. It'd be really hard. I wouldn't do this to you, I promise. But imagine it was a 5-year one. You'd have a 5-step tree, right? Years 0, 1, 2, 3, 4, 5, right? At year 5, you calculate your payoffs. You bring them back to year 4. You can't early exercise there, right? So then you bring them back to year 3. You can early exercise there. Make the decision, do you early exercise? Bring back to year 2, do you make the decision, do you early exercise? Bring back to year 1, do you make the decision, do you early exercise? Bring it back to year 0, you can't make the decision there. So you just bring back the values. Right? That's how you would value it. Right? And you have the knowledge, right? You may not think you do, but you would have had the knowledge, right? Because you know how to value European and American. Because this is kind of American in nature, you're hopefully sitting there thinking, okay, well, I'm going to use the binomial. I can't early exercise at these nodes, so I won't. But where I can, I'll think about doing. I promise you I would never give you a 5-step binomial tree. It would take you 3 hours to solve it, right? So, right, maximum's 3-step. So even that's a bit nasty. But those are sort of decisions, right, that you'd have to think about, right? So you start thinking about them. Then there's things like shout options and look back options, where you can look back in the past and you can choose a price, right, through the life of the option as the exercise price. So it's not fixed at the beginning. You kind of choose it at the end, right, if it's a look back or it's a shout. Or in any particular day, you can shout and you can say today's price. And today's price would be the exercise price of the option. Right? So how do you value something like that? That's pretty tricky. right? Because when you buy it, you don't know what the exercise price is going to be. The person chooses the price through the life of the option. Then I ask the other question, what's the point of that option? I don't know. Right? What's the value in that option? Well, some clever investment bankers came up with it, right? And they're making some money out of selling it, but what's the point of it? Okay, we'll try and make an argument next week that there's a kind of a point to them, but it's kind of difficult. Okay, are there any questions on what we did here? Okay, so you've got, if you look back at, there's 4 past final exams up on Waddle, so that's plenty. As you go through them, you'll notice they all kind of look the same, right? There's only so many ways I can ask you to do a delta hedging, only so many ways I can ask you to do a Black Scholes, right? I've got to ask you to do things like that. I'm not saying they're going to be in the final, but if they are, I mean, there's only so many ways I can ask you, right? It's just different numbers. Okay, but have a look at those. Start having a look at those exams. You should have now, right? Have you all got your email? About your final? Good. You've all got your email, so it's in the sports hall, which is good. But yeah, so start looking at those. If you've got questions, right, come and see me. Ask them in these lecture times, right? But next week's kind of I think it is. You may not. I think it's kind of a fun lecture, right? Because we look at some of these weird sort of derivatives that are out there in the marketplace. Okay, so they're kind of cool. Okay, I'll remain at the front if you have any questions. Thank you. Thanks, sir. Thanks.
Because it was the writer? Yeah, that's right. Because the holder will get that positive payoff, the writer gets a negative payoff, right? And then C, so there's the profit. So call option premium, and then minus the payoff at the end. So the rating is the wrong position? No, the writer's in the short position. Oh, sorry. Yeah. So holder is long, writer is short. So the rating gets the whole opinion. Yes, that's right. So if it was the holder of the option, it would have been this minus C, right, the other way around. Is that okay? Yeah, cool. Okay, that's good. Yeah, so when you calculate this, so J minus L minus 1, that's going to give you, say, 2%, so 0.02. That's the percentage increase. Cool. But in terms of you're told that you get $100 per percent, so if you set $100 times 0.02, that will give you $2. So you need to convert that 0.02 into actually a whole number, right? So saying 0.02 times 200 means you're going to get $2 of the $100. Is that okay? Well, see, look, if you just said J over L, that would give you 1.02, but you're not going to get $102, right? You get $200. So what you say is J over L minus 1, that gives you a 2%. But 0.02, which is what you have in there, times 100 gives you $2, right? So you're told you get $100 per percent. So you need to convert that 2% to like a whole number, not a decimal point. So multiplying by 100 means you get two lots of $100. Is that all right? Yeah. So they're not related at all, right? No. So for the American, it's complete. We don't do their rating. The Americans beyond the scope of the score. So that goes with the European. So we do European equal parity. We do European local parity. But we do American. typo. Okay, so you buy low, sell high, right? So you buy the put option because it's undervalued. And then what you do over here is you need some money to fund this. So what we say is you're going to sell the high one, right, and buy the low one, right? So essentially you borrow the present value exercise price because that gives you the money, and then you invest in the present value of the futures price, right? So you want to receive that amount, and you want to get rid of that amount. So to receive that, you have to borrow it, and to get rid of that, you have to invest it. So that's all we say. Yeah, so you're going to borrow that amount and invest that amount. So you borrow the high amount and invest the low amount. Yeah, so whichever one's higher. In this case, X is higher, so you borrow that amount and you invest that amount. Because you need to fund the strategy. Because you need to fund the strategy, and that's how you fund it. And you need to do these amounts because that's how you get the relationship in terms of the arbitrage of opportunity in the marketplace. So the rule is always buy or sell the option depending on what. So in this case, it's low bounds violence. You're always going to buy the put option or buy the call option. And then over here, you're going to always borrow whichever amount's higher, either X or F0, and then you're going to invest whichever's lower, X or F0. Correct, that's right. Is that all right? Okay, cool. Thank you. Any other questions? Anyone have? Sure. I'm here.